Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the exergy and its destruction for the working fluid. The total energy of the working fluid includes internal energy, kinetic energy, and potential energy. The exergies of kinetic and potential energies are equal to themselves, and they are entirely available for work regardless of the temperature and pressure of the system. However, the internal energy U and entropy H of a system are not entirely available for work. Taking a closed system as an example, as shown in the figure. When the temperature and pressure of the working fluid are different from ambient temperature and pressure, the working fluid then can interact with the environment to carry out a process until the temperature and pressure of the fluid are the same as the environmental temperature and pressure, and the process can no longer be carried out. In this process, the working fluid makes available work to the surrounding. If this process is reversible, the available work done to the surrounding will be a maximum. This available work is different from the expansion work. When the gas expands, the expansion work made to the surrounding, which includes a part of unusable work made to the atmosphere, P0 times V0 minus V. The rest is useful work. The surroundings work, WSURR equals P0 times V0 minus V, is the work done by or against the surroundings during a process. When a system is expanding and doing work, part of the work done is used to over the atmospheric pressure, and thus WSURR responds to a loss. When a system is compressed, however, the atmospheric pressure helps the compression process, and thus WSURR responds again. Note that the work done by or against the atmospheric pressure has significance only for systems whose volume changes during the process. It has no significance for cyclic devices and systems whose boundaries remain fixed during a process, such as rigid tanks and steady flow devices. The process of changing the working fluid from T to T0 must be a reversible adiabatic process, and then a reversible constant temperature process and T0 temperature to make the pressure reach to P0. By these two reversible processes, the maximum available work done by the working fluid to the surrounding is. The maximum usable work is called working fluid exergy, denoted as the working fluid exergy is. Exergy for the working fluid is a state property, which means that for a certain environment the theoretically usable part of the internal energy of the working fluid at a given state can be converted into usable work, or exergy is the working ability of the fluid at the given state. This working potential can be fully output in the process of making the maximum available work to the surrounding during a reversible path from this state to the environment. When the working fluid in a closed system proceeds from state 1 to state 2 with the only reservoir of atmosphere, the drop of working fluid exergy should theoretically equal to available work made to the surrounding. Due to the irreversibilities of the process, the available work actually made by the working fluid is always smaller than the exergy drop of the working fluid. The difference between them is the exergy destruction. When the atmosphere is the only thermal reservoir, the heat rejection of the working fluid is also the heat addition of the atmosphere, and the exergy destruction is. Okay, that's all for this task. Thank you very much, and see you next time.